Hello dear students, in this session we are going to solve a numerical on shear stress at different sections. In this question we are given with a rectangular beam of 100 mm wide and 250 mm deep. It is subjected to a maximum shear force of 50 kN. Determine the average shear stress, maximum shear stress and shear stress at a distance of 25 mm above the neutral axis. So this is the question of shear stress where we are given with a rectangular beam. It is of 100 mm wide and 250 mm deep. It is subjected to a maximum shear force of 50 kN. We have to find the average shear stress, maximum shear stress and shear stress at a distance of 25 mm above the neutral axis. So let us solve this problem. In this question, we are given with a rectangular beam of cross-section area 250 by 100 millimeter, right? Depth is given 250 and width is given 100 millimeter. The maximum shear force acting on the beam is 50 kilonewton. We have to find out the average shear stress. What is the average shear stress? This we have to find out. The maximum shear stress and the shear stress at a distance of 25 millimeter from the neutral axis. These things we have to find out, right? We already know the formulas. Average shear stress is the force, whatever is the force per unit area upon the cross section area, which is 250 by 100, right? This is the average shear stress. Maximum shear stress, go to the theory lecture. Maximum shear stress is given by 1.5 times the tau average, and the shear stress at any plane of this figure is given by f by 2i d square by 4 minus y square, and this is a parabolic variation, right? So you know this variation of shear stress at this cross section is parabolic, right? This is known to us like this, and this is maximum at the center, and this is 0 at the outer peripheries. At outer peripheries this is 0, and this is maximum at this point. This is tau max, right? And at certain distance 25 mm, this will be the tau, right? Tau at 25 mm, right? So these things we have to find out, right? So let us start the question. How to solve this question? So first of all, find out the tau average shear stress. Average shear stress is the given force per unit area, total area of this cross section, right? So force is given 50 kilonewton, area is given to us 250 by 100. By this we can find out the tau average shear stress in Newton per millimeter square or megapascal, right? So what is the value? Tau average, I am writing directly the value. Tau average is given by 2 Newton per millimeter square. So this will come out to be, is it 2? Yes, it is 2 Newton per millimeter square or 2 megapascal. So this is the average shear stress. You can see here the average shear stress or shear stress on the beam is very small, right, as compared to the bending stresses. That's why bending stresses dominate, and sometimes we neglect shear stresses, right? So this is the average shear stress. It is very small as compared to bending stress. So 2 Newton per millimeter square is the average shear stress. Now what is the maximum shear stress? Maximum shear stress, tau max. This is 1.5 times the tau average. So this will be equal to 1.5 times 2, right? So how much this is 3 Newton per millimeter square. So you can see that tau maximum, even the maximum stress is very small. Maximum stress is very small compared to bending stresses, right? And at the center, maximum bending stresses are, shear stresses are maximum and bending stresses are 0 at the center, right, at the neutral axis. So this is 3 Newton per millimeter square. Now we have to find out tau at a distance of 25 mm from the neutral axis, right? So tau will come out to be f by 2i. But what is I? What is moment of inertia? that is BD cube by 12. This is B and this is D. So this is BD cube by 12. So this will come out to be 100 multiplied by 250 cube by 12, right? So this value can be used. This is mm to the power 4, right? This is the moment of inertia. So tau will be equal to F. Maximum force is given 50 multiplied by 1000 Newton divided by 2I. I is this value. This is 100 multiplied by 250 cube BD cube by 12 multiplied by D square by 4. D is the depth. This depth D. This is 250. So 250 to the square by 4 minus Y square. Y is given 25 mm. We have to find out at 25 mm. So 25 square by 4. So this is mathematical calculation. Use this and you will get the shear stress at a distance of 25 mm from the neutral axis. So it will come out to be 2.88 Newton per millimeter square. So this is another answer. So these are the answers of this question. The average shear stress, maximum shear stress and the shear stress at a distance of 25 mm from the neutral axis. You can see here that the maximum shear stress is 3 Newton per millimeter square, which is very small, and this tau is near to this value, near to 3 value, because this 25 mm is very close to neutral axis, right? That's why these two values are very small, very close to neutral axis, right? Because total depth is very large, right? 250 millimeter. So this is how we can find out the shear stresses.